Welcome back to 6-Minute Math, where we turn confusion into clarity 6 minutes at a time. Thank you for joining us today as we are going to explore multiplying polynomials using the distributive method, the extended version. We will not have a time limit today as we want to ensure we take all the time we need to learn the process and explain each element that goes into multiplying polynomials. Our key points when we are multiplying polynomials using the distributive method is we are going to multiply each term in the first polynomial by each term in the second polynomial. At the end of everything, we are going to collect all of our like terms for a final answer. So let's check out this example of x plus 3 times x plus 2. I'm going to isolate that first term and multiply it by each term in that second polynomial. X times x is x squared. And then x times positive 2 is 2x. I am done with that first term, so I'm going to isolate the second term, positive 3, and multiply it by each of the terms. 3 times x is 3x, and then 3 times 2 is 6. At this point, I'm on to my last step of collecting like terms. I only have the 2 in the middle, so therefore my final answer will be x squared plus 5x plus 6. Let's check out some examples. We're going to expand negative x plus 2 times x minus 6. So for each of my examples, I'm going to take different colors for each of my terms. We're going to use pink for this first term, and I'm going to multiply it in. Negative x times x is negative x squared. And then negative x times negative 6 is positive 6x. We're going to multiply now this second term in. So I have 2 times x and then 2 times negative 6. 2 times x is positive 2x. And 2 times negative 6 is negative 12. And then I collect my like terms. I have my like terms of x, which gives me a final answer of negative x squared plus 8x minus 12. Let's check out another example. We have y minus 4 times y minus 7. I'm going to take that first term and I will actually do the multiplication in pink here. So y minus y is y squared. And then y times negative 7 is negative 7y. We're now going to multiply the second term by each of the terms in my second polynomial. Negative 4 times y is negative 4y, and negative 4 times negative 7 is positive 28. Collect my like terms in the middle here for a final answer of y squared minus 11y plus 28. How about another example? We are going to multiply this in, so our process remains the same. I'm going to multiply my first term in. X squared times x is x cubed, and x squared times negative 9 is negative 9x squared. We'll multiply this 2 in. 2 times x is positive 2x, and 2 times negative 9 is negative 18. I do a quick scan and see that I don't have any like terms, which makes x cubed minus 9x squared plus 2x minus 18 my final answer. How about if I expand the following? I have a binomial times a trinomial here, but nothing changes in my process except for that I have to multiply by one more term. X times x squared is x cubed. X times positive 2x is positive 2x squared. And x times negative 4 is negative 4x. I now take that second term and distribute it into each of the terms in my second polynomial. So I have negative 4 times x squared is negative 4x squared. Negative 4 times 2x is negative 8x. And negative 4 times negative 4 is positive 16. I collect my like terms. In this case, I have an x squared, but I also have the x values, giving me a final answer of x cubed minus 2x squared minus 12x plus 16. Let's check out another example. I'm going to distribute my y into each of those terms. Y times y squared is y cubed. Y times negative 7y is negative 7y squared. And y times negative 8 is negative 8y. I now take my 3 and multiply it by each of my terms. 3 times y squared is positive 3y squared. 3 times negative 7y is negative 21y. And 3 times negative 8 is negative 24. And then I collect my like terms. Couple y squareds and a couple y's, for a final answer of y cubed minus 4y squared minus 29y minus 24. One more binomial times a trinomial. X times x is x squared. X times 3y is positive 3xy. And then x times negative 11 is negative 11x. Negative 7 times x is negative 7x. Negative 7 times 3y is negative 21y. And negative 7 times negative 11 is positive 77. In this case, I only have my like terms in the middle, giving me a final answer of x squared plus 3xy minus 18x minus 21y plus 77. On to our last example here, where we are going to multiply a trinomial times a trinomial. So nothing's going to change in my process. We just have a couple more multiplications to do. I'm going to distribute my x squared into the second trinomial. X squared times x squared is x to the fourth. X squared times 3x is positive 3x cubed. And x squared times negative 6 is negative 6x squared. For my negative 2x, I'm going to distribute that into each of my terms as well. Negative 2x times x squared is going to be negative 2x cubed. Negative 2x times positive 3x is going to be negative 6x squared. And then negative 2x minus 6 is going to be positive 12x. And then my last one I will do in yellow. We're going to multiply my 2 in. 2 times x squared is positive 2x squared. 2 times 3x is positive 6x. And then 2 times negative 6 is negative 12. Now I have stacked my answer like this with each like term vertically, as it will help me keep everything organized. We have in x to the 4, 3 minus 2 is a single x cubed. Negative 6 minus 6 is negative 12, plus 2 is negative 10x squared. 12x plus 6x is positive 18x. And then I have a negative 12 by itself for a final answer. Those are all the examples I have today for multiplying polynomials using the distributive method. Please follow us on Instagram and TikTok at 6Minute Math, and be sure to like, share, subscribe, and leave a comment below for any topic you want to see me tackle in a future 6-minute episode. Always remember that the best way to get math is to practice math, so keep on practicing. And until next time, keep solving and evolving.